Good morning to everyone. Good morning, sir. My name is B.keerthi from CCM Department, second year. Today, my topic is about finding a generating function for recurrence relation. Finding a introduction to generating function. Generating functions are powerful tools in the combinator. They provide a way to encode sequence and solve recurrence relations. This presentation will focus on how to drive the generating function from the recurrence relation. Here is the generating function g of x is equals to sigma k is equals to 0 to infinity a k x of k. What is the recurrence relation? A recurrence relation defines is a sequence based on the previous terms. It provides the formula for calculating the future terms giving initial conditions. Understanding the recurrence relation is the essential for finding its generating function. Types of recurrence relations. There are the linear and non-linear recurrence relation. Linear recurrence relation can often be solved using the generating function. The order of recurrent relation indicates how many previous terms are involved. Definitions of a generating function. The generating function of a sequence is a formula power series. It is typically expressed as g of x is equals to a of 0 plus a of 1x plus a of 2x into 2 plus so on. These representations allow for manipulations using algebraic techniques. Here you can see the definition a of 0, a of 1 up to infinity a of n. Be a sequence of real numbers and set. Here is the formula a of x is equals to sigma j is equals to 0 to infinity a of I x of j, where x is the dummy variable. If the series convergence is some real intervals minus x naught x naught, then the function a of is called the generating function for the a of j. Steps to find a generating function. Identify the recurrence relation and initial condition. Multiply the generating function by appropriate power of x. Use the recurrence relation to express it in terms of g of x. Examples recurrence relation. Consider the Fibonacci sequence defined by f of x is equals to f of n minus 1 plus f of n minus 2. The initial conditions are f of 0 is equals to 0, f of 1 is equals to 1. The relation establishes a well-known example for generating function. Expressing terms using g of x. Shift the series to represent the terms using the g of x. For example, f of n minus 1 corresponding to x g of x and f of n minus 2 corresponding to x into 2 g of x. This led to the equation g of x minus f of 0 minus f of 1 into x is equals to f of x of g of x plus x into 2 g of x. So here you can see the example. F of x is equals to 3 by x minus 2, g of x is equals to 2 by x. Replace the every x in the f of x with the g of x by 2 by x. Solving for the g of x, rearranging the equation L g of x 1 minus x into 2 is equals to f of 0 plus f of 1x. Substituting the value known initial condition to simplifying. Solving for the g of x give as a closed form expressions. Convergence and the radius convergence. Generating function may have a radius of convergence. The radius is determined by the growth of the sequence. Understanding the convergence is crucial for applying the generating function in the analysis. Applications of a generating functions. Generating functions are used in the combinator counting problems. They help in the solving differential equations and the recurrence relation. Applications span computer science, physics, and probability theory. Summary of the key points. Generating the function provides a method to solve the recurrence relation. The process involves refining the series and manipulating it algebraically. These techniques can be applied to a wide range of mathematical problems. So here is the given problem to solve to find the generating function a of x from the recurrence relation. The given equation is a of n plus 2 minus 3 a of n plus 1 plus 2 of a of n is equals to 0 from n less than or equals to 0. Sorry, greater than or equals to 0. With the initial condition a of 0 is equals to 1 and a of 1 is equals to 6. We produce as follow. Define the generating function. First, the generating function is the formula a of is equals to sigma n is equals to 0 to infinity a of n x power n. Shifting the series to express n is equals to 2 and a of n plus 2 x power n sigma n is equals to 1 infinity a of n plus 1 x power n and sigma n is equals to 0 sigma a power n x power n with shifting the indicate. So here is the next step. Sigma n is equals to 2 infinity a of n plus 2 x power n is equals to x power square n is equals to 0 infinity a power n x power n is equals to x square a power x. sigma n is equals to 1 infinity a power n plus 1 x power n is equals to x into a power x minus a naught, and sigma n is equals to 0 infinity a power n x power n is equals to a power x. This is the a power x is equals to sigma n is equals to 0 infinity a power n x power n. So sigma n is equals to 2 sigma infinity a power n plus 2 minus 3 a power n plus 1 plus 2 a power n into x power n is equals to 0, x square a power x minus 3x a power x minus a naught plus 2 a power x is equals to 0. Substituting a naught and simplifying the substituting a naught is equals to 1 in the above equation. X square a power x minus 3x into a power x minus 1 plus 2 a power x is equals to 0. Expanding and the simplifying, then we'll get these steps. X square a power x minus 3x into a power x plus 3x plus 2 a power x is equals to 0. Combining the like terms, x square minus 3x plus 2 into a power x is equals to minus 3x. Solving for the ax is equals to minus 3x. This equation will go down like x square minus 3x plus 2. Factor the denominator. X square minus 3x plus 2 is equals to x minus 1 is equals to into x minus 2. So minus 3x. So here minus 3x by x minus 1 into x minus 2. Partial fraction decomposition. Express a power x is a partial fractions. So here we will do the partial fraction for the a power x is equals to minus 3x by x minus 1 into x minus 2 is equals to a by x minus 1 plus b x minus 2. Solving for the a and b, minus 3x is equals to a into x minus 2 plus b into x minus 1. Expanding, minus 3x is equals to a plus b into x minus 2a minus b. Matching the coefficient, a plus b is equals to minus 3 minus 2a minus b is equals to 0. And here is the next, minus 3x is equals to a plus b whole power x minus 2a minus b, matching coefficient. So same, solve the system. From minus 2a minus b is equals to 0, we get the b is equals to minus 2a. Substituting into the a plus b is equals to minus 3. A minus 2a is equals to minus 3. Minus a is equals to minus 3. A is equals to 3. So a of x is equals to 3 by x minus 1 minus 6 of x minus 2. Generating function a of x is equals to 3 by x minus 1 minus 6 by x minus 2. This is the final answer for this question. Conclusion for this, understanding the generating function is essential for advanced mathematics. They offer a systematic approach to analyzing sequence and the recurrence. With a practice, finding the generating functions can become a valuable skill. Thank you for giving this opportunity, sir.